Oh, that's online. Okay, wonderful. All right, well, as I mentioned to you last time, we have an exciting treat for us here today. Dr. Rice has agreed to join us. He is probably the climate change expert here and around the world as well. So he's been recognized in multiple places, and he's agreed to kind of give us an introduction of agriculture and climate change and what it's all about. So I won't take up too much time because I know he has plenty planned all the way to 6:30 apparently. So all right. Thank you again for joining us. Oh, we have to actually put it up on the screen and they're not going to see it.
Oh, are you seeing it where?
Well, they'll see it both places.
Oh, okay.
It's a little hard to see at the back of the room without this one. So.
Is that working?
Yeah, it's a little slow, but it's
okay. All right. So while it's coming up, so I hope to make this interactive, ask lots of questions, and we will go to 6:30. But I want to kind of touch base. The way I want to do is kind of talk about some basics about climate, and we'll bring in some of the controversy. And if you have different views, that's fine as well. And then we'll talk a little bit about the impacts that current changing climate, as well as some of the future projections on climate for agriculture, bring in a little bit of Kansas perspective. And then I'll actually, if there's time, end up a little bit about some communication and people's perspectives on climate. That we had a project where we did some surveys in Kansas a couple summers ago. So that's the goal. So anyway, with that, no? So I lose my, okay.
It should have worked. Okay.
No, that's fine. Okay. Do it the old-fashioned way. Maybe not.
Huh. I practiced ones I advanced slides, I swear. Because of the name.
Or I'll have to do the arrow button, I guess. Okay. So I apologize for the ones that are online. I'm going to walk around the room. So my question is, that's up here, what's the difference between climate and weather?
Sounds like climate is bigger. Like weather is maybe like more local.
Okay.
Climate is more long-term.
Okay.
So you would talk about climate. So there's like arable climates, then there's weather events that happen within the climate.
Okay.
I always viewed climate more patterns of weather in a specific area.
Okay. So the weather is really short-term, what's happening in a short-term basis, and that's kind of, people define it different ways. Climate is really long-term trends. Okay. And one way that somebody explained it to me was weather is what you're wearing today. Climate is what's in your closet, the clothes in your closet, your whole wardrobe for the whole year. So, that's one way to look at it. And so today, and so we're going to talk about climate change. If you're thinking about on a very short-term basis, say there's no global warming or no climate change happening or extra cooling, you know. But if you're in Australia today, it's 122 degrees Fahrenheit. They're breaking all kinds of records. So they would have an opposite view of today. But it's really the long term. And so keep that in mind in some of the discussions and that. I guess as we go along, there's some debate on climate change, climate skeptics or climate deniers, and you may be one of those. But I'll try to point out some of those differences, and if you have questions or don't agree, that's fine too. So I can't do that, can I? Okay, So one thing, and we're going to get to some really basic material here I think you need to understand. And you need to understand the so-called greenhouse effect. All right? Everybody familiar with that? And then I can just, all right. So if we didn't have these greenhouse gases and the greenhouse effect, we'd have a climate more like Mars. Okay? And it'd be colder than today all the time. All right. So the greenhouse effect is actually a good thing. It keeps our planet warm. The question is these so-called greenhouse gases, which are primarily made up of carbon dioxide, water vapor, there's methane, nitrous oxide, and a few other things. They actually allow sunlight to pass through, and then they, as heat energy bounces off that land surface, is those gases trap some of that heat and warm the atmosphere. And that's why we have the conditions that we have now. The question is, if we're increasing these greenhouse gases, will we warm the planet more than normal? So, given that, this shows 3 of the greenhouse gases, carbon dioxide, methane, and nitrous oxide for the last 1,000 years. And what you should see here is that all 3 of those gases have increased dramatically, particularly in the last 150 years or so. And these are not, these are actually measured values. The last 100 years or so, 120 years, are actually towers that measure those gases in the atmosphere. The first one was set up in Mauna Loa, Hawaii. Besides being a nice place to go, why would Mauna Loa be a good place to measure atmospheric gases?
It's not on the mainland, so as weather comes through, as winds come through, I guess they will carry out those gases too.
Okay. Yeah.
Pretty far away from the rest of civilization.
Right. So it's right out in the middle of the ocean. And so if you ever had a tower in Chicago or LA or Paris, you'd have a lot of local influences. And being in Hawaii, and because the gases, once in the atmosphere, they circulate around the world, they get evenly distributed. So it's a good place to measure without human or industrial influence. So that's the reason for that. Now they got other stations now elsewhere, but that was the original site, and it just celebrated its 100th anniversary a few years ago. So these are actually measured in the atmosphere. And then these are actually measured, but they're measured from ice cores taken from Antarctica. And the deeper the ice, the older it is, and there's ways to measure that. And I've had the fortunate experience to be at the New Zealand station in Christchurch, where they actually store the ice cores. And so what they do is they bring them up, ship them to Christchurch, store them at minus 80 degrees C, and then they work in a workroom at minus 20 degrees C, so you don't stay in there real long. But then they cut up sections at different depths, would be different ages, melt that ice and measure the gas that's trapped, because when the ice forms, the atmosphere at the time when that snow formed is entrained inside that ice core. So these are actually measured values. And so at this step here, you can kind of correlate or do a fact check, essentially, to measure what's in the recent snow in Antarctica and make sure it's correlated with the current atmosphere. And so that's one way they collaborate those 2 different types of measurements. So these are actually measured values in that primary for the ice cores going back to 1,000 years or so. I can't do that. Oh, I can do that. It started working. Okay. All right. So we know that those gases have increased dramatically. When I arrived here at K-State 25 years ago, we were doing a project looking at the effects of elevated CO2 on the prairie. and the background atmospheric concentrations were 350 parts per million CO2. Okay, I guess I can go back. So back at 350, they've been pretty much at 280. Today, actually in April of this past year, since it's 2014, April of 2013, they crossed over 400 parts per million. So in the 25 years I've been here, not because of me, but they went from 350 to 400. Okay. So that's actually, so that graph is a little bit out of date. All right. So we know those greenhouse gases have increased dramatically. The question is, and we know that it's a physical fact that CO2, methane, nitrous oxide, and those gases absorb heat. That you can't. That's a physical fact, law of nature. All right. So the question is, does that increased gases change our climate? And the climate's much more complex. All right. So what I'm showing you here, and I just got the number for 2013, so it's not up there yet. I'm showing you here from, I forgot now, right around 2001 to 2012. The global temperature, this is the global average temperature for those 10, 12 years. Okay, so how would you interpret how that climate, what's happening to our global temperature based on what I show you, so what's shown here? Is it going up, going down, not changing? What would be your interpretation?
I have a question.
Yeah.
So is this showing the increase, or
This
or
is,
or like a change, or is this like a baseline?
what you see here is a zero line as an anomaly, so it's based on a 30-year average. 61 to 1990 is the average, and anything above or below. But it doesn't make any difference. The average will just go up or down. So this is showing you the change over that baseline. Okay, so but the point is, so the real temperature, you just add that baseline to that value of 0.6 degrees centigrade or so. So, but over the last 10, 12 years, how would you say our climate is changing or not changing? Go ahead.
Well,
just on that record.
Yeah, from that decade, it's compared to the baseline, it's obviously higher.
Right, but how is it changing over that 10, 12-year period? Huh? It's variable, and I would argue it's flat. And when I show you the whole data set, it'll be a little bit different. But this is 1998. That kind of shows right there. And before the last couple of years, some of the climate skeptic people, they use this data and say, well, our climate's not changing. Okay? And they'll actually, before these couple of years, they'll take this point and this one, and they say, actually, it's cooling. Okay? What did I ask at the first part of the class? Climate is long-term trends. Climate is not a decade. Okay? We got natural cycles, and there are natural cycles, and I think I'll show a slide of that. Yeah, a couple slides. But it's really the long-term trend. Whoops. Does your interpretation change a little bit? At least it does for me. Okay? Now, I can pick any point in the last 130 years and say, boy, we're in global cooling. You know, even in this period from 1910, if you draw that line, it's increasing. And then from here to here, it went from cooling cycle. So if you look at 10 or 15-year records, I can make any interpretation I want to make. Okay? It's the long-term trend. And so at least my interpretation, and most climate scientists would argue that we're in a warming period, especially if you go through here, all the way, yeah, there's some variation, but the trend strong trend in my mind that it's increasing. And there's some variability there. And particularly since 1950 or so, and certainly since 1980, global temperatures have increased. Now, some of the people would argue, well, we're flattening off. Again, 10 years is, yeah, we could say it's starting to flatten off, but there's some other data that would show, if you look at, this is just air temperature, if you look at oceans and deep oceans, they're warming, so some of that ocean is absorbing the heat, but if you combine those, we'd still be warming, putting more energy into the planet. So that's some of the records, although, like I said, some people want to debate that. No, this doesn't show. Okay. So, you know, okay, so that's only in 100 years. Okay, what about longer time periods? Well, this is not showing temperature, but it's showing carbon dioxide concentrations. And there are some natural cycles, and you can see back to 450,000 years. I wasn't around that time, but there are some cycles here that even before humans were around, that there were these natural cycles. Okay, but and this doesn't show. Like I said, today it's right around 400, so this is even a little bit. But look at the last time frame. CO2 has increased. My interpretation, CO2 has increased dramatically at a rate that's unprecedented and at a higher level than the last 450,000 years. Okay. Okay. Where's that CO2 coming from? This is a little bit out of date. It's from the IPCC assessment, the 2007 report, the 2014 report, the basic physical science report came out last fall, and the mitigation and adaptation sections, which I'm part of, will come out in April, March and April this year. But in 2004 data, so it's a little bit out of date, but of the anthropogenic greenhouse gases, and that CO2, methane, nitrous oxide, and the chlorofluorocarbons are the primary ones. Globally, 57% is coming from fossil fuel use. We need energy, and we tend to use fossil fuels, coal, oil, natural gas, but primarily coal, for electricity, at least for electricity. There's effect of deforestation, methane increase, and then nitrous oxide to some extent. That's on a greenhouse gas. If you look at it by sector globally, again, energy supply is accounting for 26%. Transportation globally is 13%. Agriculture represents about 13%, which is mostly nitrous oxide and methane. So that's the global picture. If you want to look at it by U.S. or Kansas perspective, U.S. is over here. And that electricity is about 33%, so a little bit higher than the global average. Transportation is double than what is globally, but we're a large country and we do not have a mass transportation system like they do in other parts of the world. And then agriculture only represents 8% on a U.S. basis. For Kansas, we're about the same as far as 34% electricity, but ag is a much bigger footprint, partly because we're an ag state in that. So it represents more like the global percentage in that. Okay? Questions? Except feel free to stop me as I go on. All right, so that gives you a little bit about CO2. And so the question is, and a lot of people say, well, yeah, that's CO2, and there was warmer periods on the Earth. And, you know, people want to, there's different interpretations and different analysis. This is, and they always talk about the medieval warm period. This is one interpretation of that. And looking at different records, and 2004 shows up here, looking back to 2,000 years ago. There is the medieval warm period in here, that shows up. But basically, these are different models or estimates, means for estimating temperature. We didn't have thermometers back 2,000 years ago, but there's ways to estimate, like tree rings and other coral growth, to estimate temperature growth effects. And you can see here that, at least by this analysis, that in the last in the decade 2000, that we're at a higher point than any time, even over the medieval period. People would argue with that, but yeah, this is one interpretation. Yeah.
Just caught my attention because I'm from Costa Rica, and
Okay.
at the University of Costa Rica we had a guest speaker that gave a talk, and it was called "The Cold Side of the Global Warming."
Mm-hmm.
You have heard about it, but I sincerely didn't do much research after that. But it seemed interesting to me because what he said is that there was some samples taken from a lake in Russia on the Siberia.
Mm-hmm. Yeah. Okay. I think I know what you're talking about. Yeah.
And what they found out is that after different warming periods
Mm-hmm.
like this, it always would show an ice age. So
Right.
he was talking about like what kind of ice age we're going to have after this.
Right. Well, and if you go back to these cycles here, these all represent ice age periods and that. So there is this natural cycle. You're right. And so the question is, are we impacting that natural cycle? So if you agree that we're warming the planet, then are we just raising? You're going to have this natural cycle, but now is it raised? And you're still going to have the cycles, but are you accentuating it? And that's the one interpretation argument. You got to be real careful, and that's where the medieval warm period. Yes, Europe was extremely warm during this period, but on a global basis, it shows up there, but it doesn't accentuate. It's not exaggerated. Where this is a global picture, and so even like North America, the last few years, couple years, this winter's been really cold. A couple years ago, we had a really cool summer and that. But you got to think of it in a global picture. There's going to be variations in that. So looking at a lake in Russia doesn't tell you the global picture. Or looking at the medieval period in Northern Europe, that's only that effect, or North America. North America, the last couple of years, doesn't represent the globe. And you can pick and choose, and I'll show some maps on the future projections too, and there's a lot of variation on that. If we go back, so what I showed you was, temperature the last 2,000 years. Okay, this is going back to about 12,000 years. Even then, so you do have this cycles in that, and here actually it's trending down in the last 2,000 years. But again, the argument is, and these are obviously reconstructed, but the argument is that we're sitting here, so we are at a point higher than estimated, okay, than over the last 12,000 years. And, you know, if we keep the trend going, then we'll certainly be out of the realm. And most of normal modern agriculture and human activity occurred during this period. So we certainly are the realm that we've experienced in modern, quote, modern history since the last 2,000 years or so. So and it's not only that we're warmer, but that we're warming faster rate, so that makes it harder to adapt. And what's the effect on ecosystems? Right. So that's kind of what's happened in the past. So the question is, what's the future going to look like? Well, we don't have replicated planets that we can do experiments on. Okay. And so the only way that we can estimate what the future will look like is through the use of computer models. And there's all sorts of issues with computer models, but like I said, we can't replicate experiments and look for the future. So what you see here is the light blue squiggly lines are 23 computer models looking at climate models. And the dark blue line is the average of those 23. The black line is observed temperature records for the last 100 plus years. So the real observed and the model data. Now what you see here are a couple things. There are some cycles. There's a lot of variability. Volcanoes have an effect, have a cooling effect. Certain, particularly large events like Pinatubo, Agon, I'm not sure how to pronounce that, Santa Maria, all those have had some effect. They put dust up there, but generally they're, depending on the size of the event, they're 1 or 2 year effects. They reflect sunlight back, so you have less energy coming into the system. So they do have a short-term effect. But the models tend to incorporate that. And then they also incorporate the natural solar cycles. The sun goes through some cycles as well, and that affects our climate as well. So if you, okay, so my question is, what do you observe, how the models are performing with the observed measured temperature? This is an interactive class. Go ahead. Yeah. So how well do you think the models are matching up with the observed temperature records?
Not well. They're lower, especially recently.
Special reason. How about earlier?
They were pretty accurate.
Okay. They kind of, you know, they're not perfect,
Right.
but they're in the ballpark at least. We were talking about football earlier. But since 1960 or so, there's a divergence. Okay, the models are only including the natural forcing factors right now in this graph. Okay, now if you plug in the anthropogenic factors, okay, the greenhouse gases, the soot, other things, this is what the model does. How well do the models perform now?
Really good.
Pretty good. Okay. I mean, they're not perfect, but they match up pretty well. So my interpretation is, and a lot of people's, is that yes, there's natural factors, and you're mentioning some of those, but certainly in the last 40, 50 years or so, there's a greater effect of human influence on our climate. And the models only capture that if you put those factors in, if you believe the models. Okay. And like I said, that's the best thing we have going for as far as looking future. So this is looking at measured, and then the question is now we're using these models to project the future, the next couple hundred years. And like I said, there's uncertainty with the models, but it's probably the best of what to project, not predict, project what will happen with our climate. Okay, so if you have any sort of confidence models, and you can argue, but given that this is what the projections are for temperature by the end of the century, so to 2100, and these are, I'll have to explain this quickly, the low and high emissions pathway. The low emissions, okay, so there are lots of things that are affecting our climate. There's natural, but also there's human, right? So the question is, what will the future human behavior be over the next 100 years? Okay, what's the effect of the economy? Will we do something about climate or greenhouse gases? Will we do some regulation or policy that will reduce those or look for renewable energy sources? or will we continue along the same path? And I had a couple other slides, but just to keep it concise, is basically this is the low emission pathway if we decide to do something about greenhouse gases, CO2 and other greenhouse gases, or if we kind of more business as usual. And we tend to be on this pathway right now. So, but this is projected over the next 100 years, and who knows what human behavior will be like. All right, so the low emissions pathway, what you'll see here, well, either way, the high latitudes will see more warming, higher temperatures than the mid or low latitudes. So we're looking at, on the low, the conservative, very conservative pathway, about a 5 to a 9 degree Fahrenheit increase in the high latitudes. The high emission pathway, which we tend to be more on track for, we're looking at 15 degrees Fahrenheit warmer. Nice. Okay. Now, so the high latitudes are going to have the greatest impact. That's why they talk about the Arctic melting and that. If you're in the U.S., we're seeing maybe a 3 degree. We've actually warmed Fahrenheit. We've warmed about 1.5 degrees right now. So about a doubling right now on the low emission pathway. Under the high emission, looking at a little over 9 degrees Fahrenheit. Costa Rica, about the same. I guess for both the low and high emissions as the U.S. for the most part. Okay, so the reason, what's the question? Okay, the reason I don't like the term global warming is that one, it implies that the whole globe is warming, and you notice here that actually there are spots here that there's very little warming. It's not even, and so geographic distribution is really important. If I'm living up here, I'm going to have a different impact than I'm living somewhere else. The other thing is that I prefer the term global climate change because it's not just about temperature, it's also about precipitation. And from an agriculture standpoint and water resources, I'm more worried about this than I am about temperature. I mean, temperature is part of it, but what you see here, we'll just stick to the one side, the high emissions. But look, this is up to a 30% decrease in precipitation in certain parts of the world. This region here, all the way Costa Rica, we're on the fringe in Kansas, Mediterranean region, parts of Australia, South Africa, 20 to 30% decline in precipitation. If you look at western Kansas, they only get 14 inches of rainfall already, and the projections are a 10 or 20% decline. You know, we're talking 8 or 9 inches. Okay, we're better off on this part of the side of the state than the western part of the side of the state, as far as projections. But huge implications. Where do we grow our food? It's here, 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 for the most part, are the, yeah.
And also have not only about growing food. I know that this is related to agronomy, but the scientists in Costa Rica, they even talk about global change. They got rid of the climate change.
Yeah.
Because it has implications also. For example, there are studies about plankton because of the marine current, which is moving north right now, and that has big implications in fishing, like and with all the communities in the coast, you know, and all the industry of fishing. It's a whole chain of implications.
But global change actually refers to much broader things, including land use change, or human and all that, right? But the climate change part of it also drives, you're right, the ocean currents. I'm not I haven't been sold on the tipping points, but one argument is if the Arctic melts, which go back to here, will that change our ocean currents? And there's some major currents, the Gulf Stream here, that keeps Europe warm. Will that change that, for more fresh water, change that current? And we could have a abrupt change. And this would freeze out, although it's warming the ocean current, it'd be make Northern Europe cold again. It has, the other thing that's often not mentioned is everybody would worry about CO2 in the atmosphere, but there's an equilibrium between CO2 in the air and what's in the oceans, and more CO2 acidifies the ocean, and the ocean is becoming more acid, which is going to affect marine life and fishing and all that stuff. So it doesn't get a lot of the hype that, the temperature and that. So there's this hidden thing, and there's actually some major concerns about acid water washing up along the coast here, which are major fisheries and that. That's more acid water sitting at the bottom of the ocean. It's almost coming up on the top of the shelf, continental shelf, which is where the fishing is. So, but that's not my expertise. But that's another concern that often, doesn't get a lot of the press unless you're a marine biologist. Okay, so that's kind of the global perspective. On the U.S. perspective, this is close to, it might be out now. This is the draft of the U.S. National Climate Assessment Report. It was put out as a draft last spring and for comment, and it should be, like I said, it might be out as well, publicly or officially. But the U.S. perspective, their assessment of scientists was that they would argue from a scientific perspective that climate change is happening. It's apparent in the U.S. There's wide observations, temperature, and I'll show some of those, as well as migration, other factors, ice, glaciers, and that, that's occurring, and they attribute at least part of it due to human activity. We've increased, like I said, about 1.5 degrees, and most of that's occurred in the last 30 years or so. And this gives you a little perspective. This is not projected. This is actual measure. Okay, so you don't have to worry about the models and that. This shows the climate records by decade, how they've changed by different regions of the country. So if you're in the southeast, not going to change, actually maybe a little bit cooler. All right. Again, that's why I don't like the term global warming, because it's not going to be even around the world. But if I'm here in the northern plains, you can see the trend. The trends are a pretty strong trend to me that it's warming. Alaska, Hawaii, the South, Great Plains South, we're kind of, I don't know where we fit. We're kind of in this dividing line. It's a little more variable, but I think different parts of the U.S. there's some strong trends, particularly if you're on the northern part, and that fits with higher latitudes having more warming. And if you look at from an agriculture standpoint, the corn and soybean belt, if you're not familiar with that, that's basically Ohio, through Nebraska, Kansas on the fringe, up Minnesota, in that Midwest of the United States. A lot of variability, but some clear signals, a trend at least for warmer in that region. And that becomes apparent later on here. Go to 5:30, right?
5:20.
5:20, okay. We're fine, I think. Let's see, so again from the assessment report that extreme weather and climate events have increased in recent decades. There's stronger evidence of human-related activities. And the impacts are already evident. You can go to the assessment report. I'll give a summary of that in a few places. And climate change is already affecting human health, infrastructure, water, ag, energy, and the natural environment, both locally, nationally, and internationally. This is out of their report. Unfortunately, planning for adaptation and mitigation, well, fortunately, planning is increasing, but implementation is very limited. We have a very divisive political information structure that wants to purport different views on climate and climate change. So, and you know, North Carolina with sea level rise, they were wanting to do some zoning and planning for sea level rise. The legislature said you can't use that. You can't plan for sea level rise. So climate change is not happening. So, in my mind, and I have had a debate with a local legislature. In my mind, okay, if the science is wrong, and and the climate skeptics, if I put it in that category, are right, and we don't do anything, then you know, what's it going to hurt to do something? Okay. If 99% of the climate scientists, and that's a true fact, believe that climate change is happening, and the skeptics, and we don't do anything, and they turn out the 99% are right, then we're in a world of hurt if we haven't done any planning. That's my take on message.
Sorry for taking up your time, but
no, that's fine. I'd rather have the dialogue.
A few years ago, I read a report from the Department of Defense of the U.S. Related to immigration due to climate. They would call it climate change. How does it work? I mean, in the U.S. politically, if the government has something and they just later think a different thing, how do they manage?
So okay, good question, and I can tell you some personal stories. So actually, when I came here in 1988, and the models weren't very good, and they had some huge. They're talking about 15, not 15 Fahrenheit, 15 degrees centigrade increases in that. The models weren't very good, and they didn't include clouds, and they didn't include other things, and the projections were really wild. And I was skeptical, okay? But in the model, the science has improved, and now there's physical evidence that things are changing. So I was kind of cautious, but now I think there's physical evidence, and I see some things that definitely have at least convinced me that the climate is changing and that humans are having an influence. Not, you know, it's still natural cycles, but we're definitely having an influence. So back in, sorry if I get political in this, because it is political, unfortunately. Back in the the second Bush, George W. Bush, the second Bush administration, that administration denied climate change, okay? And I will tell you a fact. I was part of reports that somebody in the White House scratched out comments on reports on climate change. I've seen those, and I was part of that. They weren't my comments, but they were scratched out, edited out of the final report. But it was interesting when I started going to some of these meetings that there was two groups that was kind of interesting on future climate change and what to do about it. One group was the insurance industry, Swiss Re, okay, and the other was defense. So so why would the insurance, we're getting diverted, but that's fine. I'd rather have this discussion. So why would the insurance companies be interested in climate change? Well, and even more than crops, it changes their risk. Okay, floods, if there's more intense storms, which I haven't talked about, the projections are we'll have more intense storm events. So if there is more more tornadoes or bigger ones, or we have hurricanes, and there's some debate about that. But they were interested, or certainly there's change in floods. There's documented evidence that we're, at least in the U.S., that we're increasing floods on the eastern part of the U.S. So they're interested from their business standpoint model. So I thought, why are they there? But then, it's kind of like the aha moment, okay? The other thing was defense, which was kind of interesting because you're right. Here's a U.S. government agency. The politicals were saying, oh, the climate change is not happening, blah, 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 blah. Defense was in on these conversations. Why did they want to know? Okay, they wanted to know where the hot spots in the future were going to be. No pun intended, but where the stress levels, because where you have water, you have water or food or whatever, they're going to drive conflict. And it's going to put stress. So they wanted to know where these were going to be so they could plan for where they need to be deploying or thinking about future for their deployment or alternative bases and that. So they were in the mix. And I've actually part of a climate leadership summit, and we had admirals in, that's Navy, somebody from the Air Force who are there at the meetings. They would speak off the record and say, we believe climate change is happening. But yet the Congress and the President were denying it.
Well, they would be fools if they didn't account that.
Sure.
I mean, even if it's not happening, but if they didn't have the plan in place.
Right. That's right. And so that's my reasoning here. It's especially since 99% of the climate scientists would agree that climate is changing and that we're having an effect, humans are. We should be planning for it. And if the 1% is right, it doesn't, then we're in a world of hurt if they're wrong. And right now, we're not planning, and that's what the report is saying. From an ag standpoint, this is frost-free season. If you got warmer climate, you're going to extend the free season anywhere from 10 days longer to, well, depends where you're in the United States, but almost a month longer a frost-free season. That's a good thing, right?
Happy bugs.
Okay. All right. Okay. So more insects, pests. What else? Diseases. What about Kansas? If I got 30 days more warmer weather, what does that mean?
You have to use more water.
Use more water. Two things. One, you got a longer growing season. Yeah, that's great, but the water is the limiting factor in Kansas. And you've got means more water needed by the plants, but also warmer temperature mean more evaporation. So you get a double whammy there. And I've argued with certain members of our legislature here, but anyway. Okay, so warm growing season or longer growing season is not necessarily a good thing. And this shows we've analyzed. One of our faculty members have analyzed the Kansas records. We've got 23 centennial stations in Kansas. That means centennial, they've been around for 100 years. And this is showing the trend for the last spring frost. And basically, on average, we're about 10 days earlier. I'm sorry, no, 5 days earlier in the spring, and we're gone. We have a 10-day increase in growing season. 5 days earlier in the spring and 5 days later in the fall. So, and it varies. In some areas, there's no change. But other areas across the northern part, well, it's kind of random, but on these stations, but there seems to be a consistent trend for earlier last spring frost. I'm sorry. Did I say that right? And in other words, a longer growing season. So that's true for Kansas, even with the variability. Water is really critical. And if you downscale for the I showed you the global picture, but the projections are about a 10 to 15 percent in the southwest part of the United States. Even Kansas is 5 to 10% drier, more so in the western part of the state for projection. So again, from my perspective and Kansas' perspective, for agriculture, water is a big issue, and if we have less soil moisture, that has huge implications. And unfortunately, we've got this other issue called the Ogallala Aquifer drying up, and so now you've got two forces working concurrently. Is that you got less rainfall likely and less water availability for pumping. And so, man, I think Western Kansas ought to be planning more. Sorry, the next statement won't be political, so I won't say it. Okay. So there's more proponents of more skeptics out in Western Kansas. I guess I'll say that. Precipitation. This is very heavy precipitation. So I mentioned the intense storm events. What you see is a general increase, particularly in the last 3 or 4 decades, for heavier precipitation events. Again, it's not just temperature, it's rainfall and then how that rain comes. So if I got heavier precipitation events, even if precip doesn't change annually, but I got more intense events, what does that mean? What's the implications for that? It has implications for agriculture. It has implications for those living in the cities.
Well, I mean, agriculturally, like, if you have an intense rainfall event, it's not as beneficial for crops as it is if it's spread out over a long period of time, because there's only so much, I mean, there's a carrying capacity of soil. And
Right.
can't,
Okay, so infiltration, get more runoff.
And
Okay.
then that's like sedimentary runoff, and then that will affect, so that sedimentary runoff ends up in lakes, and then those lakes are what all the city uses for water, and that's the effect on.
So I got, more intense, that means less effective use of the rainfall, and if it's more intense, the same amount annually, that's mean drier periods, longer drier periods in between. I got more erosion that impacts soil, something dear to my heart, and that means sedimentation, but also means then flooding downstream, which impacts those cities downstream. So it affects agriculture and cities as well. So yeah, and so that's something. And Stacey Hutchinson over in BAE, Bio-Ag Engineering, has said that our storm systems, storm drainage systems for flood control are not designed. They're designed back in the 50s, not for the 2010 time frame. So we're going to have to, we should be investing more in preparedness, and we're not. If anything, we're investing less. This just shows the change in rare cold events. Doesn't mean that we're going to not have these cold snaps, but just be less of them. And same thing, the rare heat events. Probably winters are going to be affected more than summers. We're still going to have the hot summers where the daytime temperatures aren't going to change as much. It's the wintertime and the nighttime temperatures that are going to be more impacted by climate change, which has huge implications on growing crops. And I think I'll mention that maybe. Yeah, okay. So, one point it's hard to get across is, okay, so if we have warmer summers and that, it's not the warm summer, it's those really high stress events. And it's really critical. Here's the optimum growing temperatures for corn and soybeans. This is for vegetative growth, and the blue or purple, that is, I guess, is for reproductive growth. This was something I'm not a crops person, but I learned working in this area is that if you see here that corn, the optimum for reproduction, in other words, pollination, is around 62 to 72 degrees Fahrenheit. It fails at 95 degrees. Okay, I didn't know that, but soybeans actually has a higher optimum and failure range than corn. Corn is supposed to be a tropical plant, but soybeans are able to adapt to high temperature. They can pollinate still at 100 degrees. All right, that's really critical. Now, okay, so what that means is I can have a nice green growing plant, but if it's 95 degrees during a critical period, and it only has to be 1 week, you lose that crop. And unfortunately, from my research plots, I can tell you 2 out of the last 4 years that's happened. I have a nice looking plant, probably going to average 180 bushel, and I ended up with 50 bushel because it was 100 degrees during pollination. All right.
I have a question.
Yeah.
Did the school do a study about how increased carbon is increasing crop yields?
Yeah.
Okay. What was the outcome of that?
Okay. Well, you're talking about K-State or in?
I read about it at K-State, but
Yeah. It is true that CO2 will benefit many plants, particularly C3 plants, which are like wheat, soybeans. C4 plants like corn, sorghum have a less benefit, but CO2 will benefit those plants. And that's actually in greenhouses, they pump in CO2 because the plants grow better for a variety of reasons. Question is, and so that's a fact, okay. But what do plants need besides CO2?
water.
They need water. Okay. Now, one of the benefits of higher CO2 is they increase water use efficiency. But the question is, there's only a limit to that. Okay. What else do they need to grow?
Soil.
Well, yeah. I mean, you're right, but from I can grow plants in water. Okay, hydroponics. Okay. But what else? If to make bigger plants, what else do they need? Huh? I heard several things. What?
Sunlight.
Okay, and let's say that's not limiting. That's usually not limiting. Fertilizer, nutrients, nitrogen. Okay. If I want a bigger plant, I'm going to have to put on more nitrogen or more phosphorus. I'm going to put more potassium. Okay. There's a cost to that. Okay. So just because I have more CO2, I'm not the person that wrote that. She's right. The CO2 benefits plant growth, but you need a few more things than that. And if you believe those projections on water, then they're not going to benefit. And in fact, when we did the CO2 project out here on the prairie, when I got here in 1988, we got 30% more growth in plants under elevated CO2. But this was native, so they weren't fertilizing, so it was native prairie. The forage quality was less, and so they were grazing sheep, but basically the cattle would have had to eat more than 30% more to get the same nutritional value. Okay, so now, or I could have put on more fertilizer, but then that's more input costs. So
fertilizers are petroleum-based, right?
Well, a lot of it is, yes. So that's petroleum based, yeah. So it's kind of, you're getting a vicious cycle there, okay? So, yes, they respond to CO2, and there's a beneficial effect, but I'll show you in the next slide or two. The net effect is negative because of water and nutrients and other things, and pests and other things. So this just shows, I showed you maize, corn, and soybeans. But this is the failure temperature for different crops. So even if you're growing, I talked to a reporter the other day. She was concerned about broccoli and tomatoes and that. And their failure temperature is even lower than a lot of the vegetable crops are lower than corn, soybeans, and wheat and that. So here, if you're looking at watermelon or broccoli, it's even lower. Okay. So somebody was in court, right? Major. Okay. So you're worse off. Okay, and then what this shows is the corn for Kansas over the last 40 years. This is dry land and irrigated corn. Okay, so dry land, you got a lot of variability. It's very risky. You got temperature and you got drought effects in there. But this was my point going back to the reproductive failure. Here's corn with irrigation, so supposedly adequate water. So water is not less limiting. Okay. Here, that 100-degree temperature during grain fill or during pollination. This is the year. These are the 2 years I said I had nice-looking plants, and they got zapped because we had 2 weeks of 100+ temperature. And let's see, 13 isn't even on there. That would be even lower than that. Okay. So even with water irrigated, it's not just the water, it's the temperature and when that temperature hits. So the farmer is going to have to deal with this. If we're going to have more variability, that means there's more risk. And so, yeah, I'm going to have some really good years, but boy, I'd better have something in the bank or crop insurance because I'm going to have some bad years as well. More bad years. So a lot more variability, more risky from an ag standpoint. So communicating that is really important. Just as an example, in 2011, Kansas, there was $1.8 billion in insurance claims because of that heat event. That drought and heat event combined. Texas, $5 billion. So does it have an impact? Sure. Not only to that farmer, it has an impact on the U.S. economy. Who pays for those insurance claims? Okay. There's crop insurance, which is a government subsidized program. So it extends not only to ag, it extends to the whole economy. It stresses that economy. I think we should be planning for it. Health, there's many effects on health. You get higher stress, heat stress, water stress. That's going to affect humans directly, either through heat waves, but certainly, and it's not going to be equally distributed, particularly people in communities that are vulnerable would include children and also the aged population, but the poor. So while I can turn on my air conditioner, not everybody has air conditioner, can't afford to. And if you're young or old, then you're more vulnerable to those stresses and that. So it's not going to affect people equally as well. And again, the point here is that we're not necessarily being prepared for those, the health industry and that for that. Urban audience, just to be equally fair, they're going to be impacted as well. We already talked a little bit about the infrastructure, flooding events, but stress on the water systems. If we're going to need more water, you've got aged infrastructure in cities, sewers, water pipes breaking all the time, and we should be investing in that despite climate change, and it's going to stress those systems more. And again, it's going to affect different communities differently. There's been some planning, but there's a lot of barriers. And I gave the example of North Carolina legislature said, we're going to deny climate change, you can't plan for it. So they prevented zoning for sea level rise. I'm not picking on North Carolina, it's just, that's a fact, okay. And so, yeah. There was a lot of uptake after Sandy in the upper East Coast. Sandy, the hurricane. realizing if this starts to happen more. So you had a few New York, New Jersey governments starting to at least plan for it. They got a lot of criticism for it by some people, but anyway. Okay. Okay, Great Plains. I'm probably, some of it's getting kind of redundant, but the main point is, summary from this assessment report, is that we're seeing impacts on our culture, not only crop, but by livestock, and we need to think about adaptation strategies. So I think this is my break. So you probably feel like this now. Okay? Okay, so I've given you all the doom, unfortunately, the doom and gloom, but there are some solutions in that, and so I'm going to spend the last few minutes here quickly going through those. Sorry, I want to give you some basis for that, and it really relates to communication and how we communicate that, and I'll try to save a few minutes for how I deal with communicating about a controversial, at least what apparently is a controversial issue. Okay, so this is the mitigation from the IPCC that was released in 2007, different strategies, and I'll spend just a minute or two. I was one of the co-authors of this report, and the 2014 report, like I said, is coming out in April. This was looking at different sectors of the economy, opportunities for mitigation. And so what you see here, this was actually surprising to me when we put all this together. I worked on the ag chapter. But if you look here, buildings has, in 2007, over the next 20, 30 years, so we weren't looking long time frame, but what we could do in the next 20 or 30 years. So what was economically viable and technically viable, or technology available right now. So buildings have the greatest opportunity, okay? What are we thinking about there? What things could we do right now?
Reduce energy usage.
Okay, and that's, so how would we do that?
Better insulation.
Better insulation, better cooling, put solar panels on, LED lights, all the things. Those are technologies we can do now, okay? And could be taken up widely and fairly cheaply, because this is, remember, this is economic mitigation potential too. What was surprising to me was that ag, depending on cost of carbon, ag actually came tied for second. That shocked the heck out of me. Okay, I didn't think, you know, so why isn't transportation or energy higher? I mean, energy is about the equivalent of ag, and I'll mention ag briefly here, but why isn't energy higher? Okay, so energy means changing our energy structure. So either more efficient use of coal or going to more hydro or solar or renewables, wind and that. So why can't we, why isn't that bigger? That's the source of CO2. Go ahead.
My idea is maybe it's expensive to make those changes.
Okay, expense.
And then, I mean, to make those changes, you would have to, in our current infrastructure, you would have to use a lot of fossil fuels in order to make those changes. Like if you're going to increase wind power, you're going to have vehicles that run on fossil fuels to get parts where they're going.
What about nuclear?
Nuclear is not only what you mitigate by using a nuclear power plant, but also the same thing about storing nuclear waste, transporting that.
All right. So, yeah, but are we going to shut down Jeffrey's energy plant? There's a lot of infrastructure there, and we can't, you know, while coal is part of the problem, we're built, the U.S. and China are built on coal, okay? We don't, how long does it take to build a nuclear power plant? You're probably too young. When they were building power plants when I was young, but in the U.S. at least. It takes probably 5-10 years to get a permit. It takes another 10-20 years to build it. Okay, you're talking about 20-30 year time frame, which is out here. We aren't going to change our infrastructure. Even with wind, the transmission lines, they're not there. Yeah, it's impossible to change, and we're not going to get rid of the coal-fired power plants. We need them. Okay, we're running all these computers and lights and all that stuff. We need energy. We're energy hungry.
No, this isn't a short term, right?
This is the 20 or 30 year high rise.
We know.
Now, if we did 100 years, then this would change. Those are technology challenges and advancements that need to be changed. So this is the short term, what we can do. So that's the issue there. Transportation, same thing. If we look at the U.S., our road system's pretty decent, but we're built on individual personal cars. We don't have a mass transportation network. Pretty sorry compared to Europe, okay? It would take decades to build, get all the permits and buy the land to go through all that. So it's, for many places, it's the same issue. It's technology, but also it's just economic to rebuild a system that is needed. Industry has some options. I'll just briefly, and maybe I won't say it. There's a lot of good options in ag. The storyline here is basically there's a lot of synergies between adaptation and mitigation and food security. So there's a lot of synergy. So it can be done cheaply, improving soil and carbon content, takes CO2 out of the air and stores it in the soil as organic matter, but also makes the soil more fertile. Okay, and I give a whole lecture course on that. So, I'm going to skip a lot of this, but there's a lot of things in ag that we can implement cheaply that are available right now. That's why ag came up so high, and it can be done globally. Okay, so I'll skip, all those. And then there's several things we can do in ag that we can adapt, because we've already, even if we quit increasing CO2, because the CO2 is already in the atmosphere, we've increased 0.6 degrees, and it's going to double, even if we stop the increase. So 1.5 degrees centigrade, or about 3 or 4 degrees Fahrenheit, globally. So we've got to, not only do we need to mitigate, but we need to adapt. And so there's lots of opportunities, great opportunities in agriculture to do that. The last thing I wanted to do, and I know I'm running out of time, sorry, was, but you asked great questions, and that's really, I don't care about whether I get through the material, I just wanted to have a good discussion. Hopefully you enjoyed that. The other thing is communicating. One of the things we have was a project a couple years ago on climate change education to look at people's views in Kansas, okay, very conservative state, on climate. Okay, I took the slide out, unfortunately, but we had 16 focus groups across the state, and we interviewed producers, K through 12, rural K through 12 educators, and rural community business leaders. They're our focus groups. I forget any, those are the three. And so we asked them what they thought. There's a book, a study called The Six Americas. I can't think of the guy's name. I've been in conferences with him. But anyway, they've done this kind of survey across the U.S., and there's 6 categories of alarm, concern, cautious, disengaged, doubtful, and dismissive. Okay, and what you see here is the Kansas perspective, and I think this is the national perspective. Basically, I was kind of surprised that it wasn't that far off from the national perspective. But what you did see, there was probably more so of the producers and the community leaders on the, no, I'm sorry, that's right. Let's see, 11%. this doesn't show it. Anyway, the producers were actually mimicked somewhat. There was probably a little bit more on the dismissive, but it was interesting when we had these focus groups, particularly the producers, okay, and this around the country, this I'm probably categorizing, but probably would be less concerned about climate change from a political standpoint. But when we met with them, we talked about, you know, what's your view of climate and weather and that. Well, they were concerned, well, my ponds are drying up, I'm planting earlier, you know, I'm worried about my cattle. This was right during the drought periods in there. You know, I don't have enough feed, I'm worried about shipping them. People from Texas trying to bring their cattle, we tell them go north. We're not getting as much snow, you know, since I've been farming for 40 years or whatever. You know what? They were saying all the right things. Or if you agree with climate change, okay, they're saying the observed effects, but they couldn't spit out the word climate change because they've been taught, because of certain media sources, you know, that climate change is a bad word, is not true. But they were observing all those things, but they couldn't say the word climate change. They just couldn't spit it out. So where did they, go ahead.
So my big question is, I mean, obviously it's divided into two different like camps, you know, and I'm pretty sure by now we know which camp you belong to. And,
really? Yeah.
But why can't the other side not accept this? Why can't they not work together? What's the reason behind this? Is it like that it takes freedom away from the individual?
Okay. All right. So, boy.
Because obviously,
can we have another half hour?
Obviously,
I can think.
obviously, this costs a lot of money to put these plans into place and all of that.
Okay.
And you know, you're talking about tax increase or whatsoever, but
Yeah.
it's probably
So you've hit it on the head. I don't know if I want to. So anybody would disagree, or I'm not trying to identify you, but are you skeptical?
I'm just, okay, so I'm not skeptical, I agree, but I'm just saying that the reason that people have such a hard time accepting this is because it's an entire change to their entire way of life and everything they've depended on their entire life. So it's going to be hard for people.
Well, they've been led to believe that, okay? But conservation, I mean, turning off lights or whatever, less or more efficient, that doesn't necessarily mean a change in life, the way your life.
That's not what I was just referring to the fact that the climate is changing in general.
Okay.
Is going to affect their entire way of life.
Right.
Producers and
Okay.
farmers,
Right.
and that's what's hard for them.
But they're the ones that are directly impacted. And they didn't mention that in the survey. They said, I'm concerned about my ponds, my water, my cattle. Okay. So, but they've been taught that climate change is a dirty word by certain news sources. Okay. Where? Well, okay, I'll be blunt. Fox News, Rush Limbaugh. Okay. Hearing ag communications, all right, or in mass communication. There are certain groups out there. Now, you need to read, if you're interested in this, read a book by, it's called Merchants of Doubt by Naomi Oreskes. She came and talked here 2-3 years ago. Oreskes, Oreskes. Okay, I think that's close. If you Google it, you'll correct your spelling, my spelling. But she's a science historian. And her thesis was she traced this climate denier aspects, and there are certain groups, and we can talk about that, that are funding this effort of what I would argue misinformation. Okay, but she traced it back to the 50s, and there was a group of libertarians they were physicists. They worked in the nuclear bomb era, but they were libertarians. And I forgot all the issues, but the one that struck me was the smoking campaign, the anti-smoking, that this group traced back, and there are certain conservative think tanks that provided a lot of misinformation that the smoking and cancer relationship was not true, that it was fine, whatever. And I went to school at University of Kentucky, and there was the Tobacco Health Institute there. Seems like a conflict there. But this same group, you can trace it back. There was another particularly important environmental issue, and I can't remember now what it was. And then the climate one, and you can trace the thread all through this of denying the science, basically, in doing misinformation and promoting the skeptics. And I will tell you, I know that this group, these groups, they get together every Monday morning and figure out who and what they're going to hammer on that week on climate. So it's a very
It's almost a conspiracy.
controlled campaign. Okay, and unfortunately, one of the funders is in our state.
So what would be your short elevator speech to a non-believer that you would?
Okay. Well, one is, and I wish when I do that, I wish I had graphs, because that's why I show that one graph and part of it blacked out. Because if you look at, it's hard for me to, say, how can you deny that? Okay. Now people will, but for various reasons. But so my thing is, okay, there's a lot of evidence for that, physical evidence, glaciers, migration patterns, and that. But the point what I was trying to make earlier, even if you don't believe in climate change, 99% of the climate science, the science suggests that. And if we don't do something, and the climate scientists are right, then we're worse off. If you're the 1% and we don't do anything, or we do something and the 1% are right, better energy efficiency, renewable energies, what has it hurt? If you look at future economies, new jobs, they say, well, they're worried about loss of jobs. Well, man, the wind power plants are producing jobs. More solar, more efficient cars, that's creating jobs. So it's not, they're worried about the old jobs. The new jobs, if we're going to stay innovative in this country, I'm sorry, I'm probably getting my campaign speech, then it makes sense that, okay, if the 1% are right and we've done all these great things,
They're not bad.
That's still a good thing. Both from an efficiency, and we're an energy-hungry country, to me it makes sense. Investing in the future, yes.
I have a quick question. So you talked about the computer models and everything like that, and I know some people debate they're just computer models.
Right.
Do you have a confidence level on kind of those general?
Yeah, actually, those graphs I showed, the stippled areas are where all the models agree, and there's a high degree of confidence. Where there's areas that are not stippled.
Like, is there a confidence, like a number?
Yeah, they do, and I can't pull those off the top of my head right now. But the IPC has some language where they have high degree of confidence, somewhat, and likely, somewhat likely. But on the temperature, it's highly likely, which means, I forgot now the exact, but it's 90% confidence that that's true.
With respect to the Six Americas study,
Yes.
I read that from the previous one to the next one,
Mm-hmm.
the trend has been like going more like towards the
middle,
middle,
right?
like people that were alarmed or dismissed
Right.
are reduced, shrinking. Do you know if the trend continues, like, being more?
Well, it really depends. See, the problem is I ask the question, the difference between climate and weather. Okay.
It depends on
So after Sandy,
Mhm.
there was a lot more people agreeing with climate change or interested in it and concerned. During the drought of 2012, particularly, there was a lot higher interest. In the good years, oh yeah, I don't know, and like even now, the skeptics are saying, well, see, we have this polar vortex, it's cooling, we should be worrying about. Yeah, it's 122 degrees. They actually had to have a new scale in Australia because they went above their categories, except whatever it was, because they had to create. So in January in Australia is breaking records. So I guess on global average you're okay because you got cold and hot. Your average is okay. So and again, it's like I said, a one-year event. And it doesn't mean global climate change, warming isn't going to have cold events. It's just that it's the long-term trend.
I don't know how much time.
I'm good as you guys are. Though.
Oh,
Fine.
I think we got
But I'd like to.
Those of you that
So how do you?
can go.
Yeah, if you have to go, that's fine. If you're in or you're bored or.
I have so many questions.
Yeah. But it's really about communication and that. And I'm working on a project with different professional societies, how you communicate and how you dispel the thing. But it's an open campaign to discredit, provide disinformation on that. And internet's great, but sometimes the internet, there's no fact checking. When news, radio or TV or newspapers, when they in their heyday, there was critical analysis, and now people blog, and science reporters don't exist. My daughter was a journalism major, but science reporters, New York Times cut out their science section. I think they have one day a week. The Washington Post, all those. There's no critical analysis. It's just and I even had, it was really disappointing because NPR had a reporter call me and says, well, I want do you know somebody that has the counter view? And I'm saying, wait a minute, it's not, okay, it's 90 to 1, not 1 to 1, from a science point of view. And it was like, okay, but we want to get the other side. Okay, then, in fact, but then have 90 people talk versus 1, or 99 versus 1. So even NPR, which you think is a little more balanced.
Is there a priority in terms of audiences?
Who to talk to, or?
Yeah.
Well, what I've been
Give
told.
your examples. I know it varies.
Well, this project we're working on, some people say, well, it's education level. Well, it turns out this 11% is very educated. They're very educated on those. They're getting where they're getting their source of information. They're just as, educated on the issue, but it's just where they're getting their source, as these people. The sense that the consensus is you can't do anything about this group. It's this group that you can probably communicate and educate. Well, I guess from my perspective, that there's more opportunity to communicate, provide communication for. You're not going to change these people's views because politically or whatever. And they've already made their mind up, and so it's the other groups that you can communicate. But scientists aren't very good communicators. I've done a lot of training, partly my daughter, but But also I've had workshops on we need to have better messengers for science. Chris Mooney, if you know him, I had a 2-day extensive workshop, drug me out, on scientists in general, not just about this issue, but science need to be better communicators. But not everybody can do that, and I'm not saying, I'm not bragging or anything, but it's been a lot of work and training to do that. I don't, when a reporter calls me, I try to call him or her back right away. That's what my daughter told me. I try to, when I do interviews, I try to find out some about the reporter, figure out the context, if they've lived on a farm or grown up in New York City, try to put a context, and I try to relay it back to them. And so that's a whole nother class time lecture. But yeah, my role is to educate the reporter as much as the public, because then they're going to get out to the thing. Unfortunately, my name has gotten out there, so it seems like I get a call once a week from a reporter, if it's particularly on climate change, yeah. But yeah, I forgot where we're going on this. But this information, so yeah, part of my elevator speech is just, try to give them the basic trends in science and relate it. And the final point is, even if we're wrong, doing some of these other things are still good. But they're worried about, the cost of that. But, to show you how entrenched it was, I gave a talk for the county extension agents not this past year, but then a couple years ago. And the county agent said, yeah, you're making good points. But just my secretary out in this county said they weren't going to let Al Gore have his way, and they're going to leave the lights on all night in the office. Okay? I'm thinking, now wait a minute. You're using tax dollars to pay for electricity despite Al Gore. Okay? If you're a conservative and worried about taxes, wouldn't you be doing the other way? It was just so it's so, our society right now is so divisive on both sides. And, I'm going to do something in spite, that seemed really stupid, just to leave the computer or the lights on just so I could burn more electricity so Al Gore couldn't have his way.
As if you would know.
Yeah, right, yeah, and, yeah, right, yeah, yeah. So, so that's what the frustrating part is. How do you deal with that, communicating that? You try to reach them other ways, I guess. Nancy Jackson, she was part of the energy project, Kansas Energy Project, and her idea was to appeal to the Kansas conservative nature and talk about energy efficiency rather than talk about climate change, but talk about efficiency in that sense, not try to get political about it. And that's actually one way kind of go through this issue through the back door, essentially. I work with a 25 by 25 group. It's 25% renewables by the year 2025, and they're ag-oriented, not necessarily, but a large part. And so they kind of have to deal with agriculture and some of the ag organizations that tend to be on the conservative side. And so they've not talked about climate change, but talk about from efficiency and opportunity for renewables. So it gets, addressing climate change issues, but coming not upfront about it. So in communicating our extension, what's told me is that, okay, we need to talk about weather and heat and drought and cattle and things, and not use the word climate change, but talk about, use language that they already know and already understanding. That was the important part of the survey that taught me was don't talk about climate change. Talk about, water or heat uncallowing and crop failures and that. That's why I like the yield productivity, even with irrigated, it's variable. And what causes that? Well, it's a drought in there and that. And so if it's drought's increasing with climate change, fine. They don't need to know that.
So just a question. So it seems like there is not the issue about the data because they're recognizing that the data. The issue is in calling it climate change.
Well, the misinformation is that they'll try to discredit that information. They'll say, okay, well, our climate hasn't changed in the last 10 years. Okay, they say, well, it's flattening off, so shouldn't worry about it. Or they'll say, well, the temperature records, they're near cities, and so you got heat island effects, so they're influenced by local. They've tried to clean out, the scientists have tried to take effect, but you can do oceans, other things, and they all show the same trend. But they'll try to discredit or pick on certain points in that. And yeah. So they're worried about, but if the libertarian side says they're worried about any regulation. And I've heard Kansas farmers, Kansas or anybody in the U.S. will say, well, yeah, but what if I do something? Okay, what about China? China is now, up until a few years ago, U.S. was the largest producer of CO2. China is now. So what about China? Okay, well, if we're more efficient, then eventually for the future, that means we're better off than China.
In terms of agriculture, is there any, I know it is a whole system and a culture of like extensive crops and everything,
yeah.
But is there any talk about organic agriculture, like, from the cultural point of view, changing patterns or ways of cultivating more bio-intensive?
Right. What I would have talked more that I cut out is looking at the whole systems and where we can become more efficient from energy use, high energy use, but where can we offset some of those carbon emissions or nitrogen emissions and that. So there is a whole set of practices. The problem is that there isn't a practice that I can recommend that will work around the world. It's a suite of practices. So there's a lot of options. So there's not a silver bullet, say do this, you'll be better off. There's lots of options, and it depends on the producer, the farmer, what he or she can afford or willing to accept. And so the good thing is there are lots of options. The bad thing is there's lots of options. You can't say do this and you'll fix the problem. Yeah. So it depends where you are. If you're in Costa Rica, whether you're a small farmer or a large farmer, what resources. So there's a little bit of good and bad with that.
We should have put you down for a part 1 and a part 2.
Well, later in the semester, if you want to have time, we can. But yeah, so your job is for the communications. You have a responsibility there to provide accurate information.
And that will be the output of this class. Will be developing some communication plans for climate change. So,
oh wow! Okay.
Hopefully, we will have a plan for addressing.
Okay.
Good. Thank you so much for joining us. We really appreciate it. Sorry I couldn't give you more time.
Oh, no, that's all right. Like I said, I'm very interested and active in this area, so, but I try to be balanced. At least, look at the science data, and
right. I think that was
so it's not